Hello everyone. So, now that we have learned about interior angles, let's do a problem about the exterior angles. We have a decagon, a 10-sided figure with 10 exterior angles, and we want to find the sum of these angles. Note that we cannot assume that the exterior angles have the same measure, and it really doesn't look like they do. So how do we approach this problem? Well, let's think back on the previous problem about what we learned about with interior angles. So we have 10 interior angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what relationship do these angles have with the exterior angles? Well, if I look at each pair of exterior ones, like this one here, I notice that it's making a straight line with the interior angle at this spot, meaning that they would add up to 180. Same thing with this exterior angle here. If I combine it with the interior, it has to be 180. And I can do this with every pair that we have. So, all in all, combining the interior and the exterior angles, we can figure out that we have 10 pairs of angles that all add up to 180. And I can express it in the following way, that the sum of the exterior angles plus the sum of the interior well, we know each pair of exterior plus interior is 180, and we have 10 pairs, so that would be 10 times 180, which is 1800 degrees. Now, in the previous problem, we learned about a way to find the sum of the interior angles. We have this new formula where we take the number of sides, which is 10, minus 2, and multiply that with 180. And we can find the sum of the interior. So now all we have to do is find the sum of the exterior. So with a little bit of math, we have that the exterior plus, now this can just be summed up like we have 180 times 10, that gets us 1800 degrees, minus 2 times 180 is 360, and that equals 1800 degrees. Now, going further, if I subtract 1800, they cancel out. And if I add 360, we have that the exterior angles equal 360 degrees. Well, isn't that pretty interesting? So we have that the sum of the exterior angles is 360. Now why is that? How can we figure out something cool or some sort of relationship that we can figure out with these angles on the exterior? Well, it turns out that the sum of the exterior angles with n sides is just 360. Always 360. It's not a really difficult proof, but we're just kind of accept this as truth. And we can just see the logic of how it would always work out and replace the number of sides. So you would just replace like a 10 with an 8, or in the proof you would just replace the 10 with an n, and you would see that all just still cancels out, and you always are just left with 360. In fact, the math is pretty easy to do. Exterior plus 180 times n minus 2 equals n times 180. And hopefully you could understand how this would eventually cancel out, like dividing by 180 or whatever. It's a relatively simple proof, but the important fact is that the sum of the exterior angles is always just 360. And this means that it can kind of be fairly simple to work with the exterior angles instead of the interior. And we'll see how we can do so in the next problem.